Hi, my name is Eric Kuntz. I'm a HyperFlex technical solutions architect working here in the Americas. And I'd like to have a tech talk, if you will, about HyperFlex and how to present it to your customers if all you have is a whiteboard. So we're going to start with what is the foundation of HyperFlex, what are the components of HyperFlex, and then how to scale HyperFlex towards the end. All right, and then we'll summarize it for you when we're all done. So to start with, HyperFlex is a hyperconverged solution built on UCS. So let's cover UCS a little bit and do a little refresher. UCS starts with a pair of fabric interconnects, and I connect them together with a little cluster link here. And then underneath that, we'll build some blade servers because that was our original foundation of UCS. So we're going to have our little power supplies down here in the bottom, and then I'm going to build out my blades. Now, those blades are then connected with the Cisco VIC up to the fabric interconnects. And one of the things that allowed us to do this is I took what was the blade profile, the settings of the blade, what made up the configuration of the blade, the firmware, the BIOS settings, all that. And we took that information off of the blade and we put it up here in the fabric interconnects. They look a lot like switches, but they're not. There's so much more. Then we put some software on top of these guys, and we call these fabric interconnects, or FIs for short. And so we can manage these entire blades from one spot and give that one plane of view into the system. And this connection here is either a 10 or 40 gig interconnect today with options coming in the future. And this is the foundation of what we can do. Now we take those service profiles and we'll extract out the identity of that server. And the beauty of UCS is I can scale this and I can add rack mount servers to this environment. And I can add a variety of different rack mount servers into this. And by adding those servers, it gives me a flexibility to take an identity that might be, if I put an identity on a rack mount server where I would have local storage, and I want to move it to, say, a storage area network, a SAN, I would build my SAN out, connect it to the fabric interconnects through either iSCSI or through fiber channel into the fabric interconnects, and then I'd present it down to my servers. I can then take the storage that was here, move it up here to my fabric interconnects. I can move my service profiles around. If I have a failure, you can take the service profile off of this blade, put it on this blade, which means I have a significantly lower need for spares inside the data center. In addition, it gives me a stateless environment that allows that mobility, that flexibility to allow the customers to scale for what the customer needs, right? So it gives us a good foundation to start with. And if you look at it, this is the foundation for the converged infrastructure that customers have been rolling out for quite a while with the likes of EMC and NetApp and IBM and Pure Storage and a host of others. Hi, I'm here to finish our discussion. We did an introduction of UCS, and now we're going to continue on with the HyperFlex. One of the things that we want to make sure when we're talking about this is what is HyperFlex compared to the rest of the market, and what are we doing to move forward? In this environment, I'm going to have a HyperFlex system drawn out, and here, because of video editing, we've accelerated that a little bit so you guys don't have to stand and wait through my drawing skills. If you look at HyperFlex, we know it's covered off of the basis of UCS. And in this case, it's rack mount servers. So we took the existing C240s and 220s, and we added our software on top of it. And we branded that as an HX220 or 240. And those are really, the only difference between them is how much capacity does your customer need. All right, from a CPU, RAM perspective, they're identical. Now it just comes down to how much capacity do we need. So let's go through some of the components that make up what a HyperFlex node is. The first thing we have is we have CPU and memory. That's the first basis. We need that CPU and memory to run our virtual machines. We take up very little amount of RAM when we run our system, and that hypervisor also needs a boot mechanism. So we put a boot mechanism in there in the form of an M.2 card. This is our place where the hypervisor is going to boot from, and it also is shared as a VMFS store. Now, in addition to that, we've put a number of drives in the system from a variety of capacities, whether it's a 960 gig drive or a 3.8 terabyte SSD drive, or it's a spinning disk system. Maybe I've got a 1.2 or 1.8, or soon a 2.4 terabyte drives for the spinning disk system. In this case, I'm going to talk about all flash. A lot of customers are going to all flash just because of the endurance and capability that we have. Now that I've got the system delivered, we rack it and we put it in the system, connected to our FIs. Those FIs have a pre-installed, pre-configured service profile. That service profile is designed specifically for the HyperFlex environment. So we've followed all the Cisco best practices and put that out there. In addition to that, in this hypervisor, all right, I've put something out in here called an IO visor, little IOV there. And what that IO visor is going to do is reach in and connect to the controller VM. So I'm going to have a controller VM running on every one of these nodes. And that IO visor is going to intercept my storage traffic designed to go to the system, and it's going to